does a straight or curved graph best fit this model? It could well be that the graph really should be a straight line, but that maybe this data point is a little low due to miscounting, or that this point is a little high due to either miscounting or bad measurement of length, or just uncertainties in the measurement of length. With 3 points, you don't know unless you have a really good handle on the uncertainties involved whether this suggests a curved or a straight path. So we want to consider uncertainties. Now, if the uncertainty in the period is, let's say, indicated by this arrow, so that we think that uncertainty is at this data point, but maybe a little above or below as indicated by this double arrow, and then this double arrow here for this one, and this double arrow here for this one. And those uncertainties might be different for different situations. When you're counting a shorter pendulum, you're more likely to miss some counts. And if you're counting a longer pendulum, of course, it's easier. If it's too long, you can get bored and distracted and miss the counts as well. So that could have an effect. But now, instead of points, we have what's really often called error bars, or something very much like it. Is it possible to draw a straight line that goes through some point on all of these error bars? It doesn't look like it. Even if I raise this point up to the top of this bar and lower this one to the bottom of this one, it's probably not going to touch this bar. So if these represent our uncertainties, we'd have to say no. Now, if there's also an uncertainty in the length, that could modify it. We have arrows this way, and maybe those uncertainties are a little bigger. And that gives us a little more leeway in where we can draw our curve. And we would basically then draw sort of an ellipse based on these data points and so forth. And then it might well be possible that the line would go through each of the 3 ellipses. So basically, due to errors, due to uncertainties, we can enlarge the region represented by our points. It actually kind of makes our points bigger, and maybe we can get a linear model. On the other hand, if the uncertainties are very small, then those points are going to be regarded as pretty good, and we're going to try to fit some kind of a curve to that data. Okay? So if you have small uncertainties, you would kind of be compelled to some kind of a curved graph. Now, exactly what kind can be informed by a mathematical model of the phenomenon that we're observing. And that's, of course, fairly easy to do for a pendulum. And we come up with the idea that we should have a power function model. And in fact, it should be a power 1/2. The period should be some multiple of the 1/2 power or square root of the length. But we don't know that at this point. Right now we're just looking at the general idea of data and how it can be fit by curves.